Very good morning, dear friends. Myself, Dr. Vikrant Sudhakar Palekar. I am working as an assistant professor in Gokhale Education Society's Arts, Commerce and Science College, Jawar, Palghar. Welcome in the new topic on the bonding and structure of organic compounds. This is the second topic from the organic chemistry chapter. So basically, this particular topic is related with the hybridization of carbon. As we know that the carbon exists in SP3, SP2 and SP hybridization. So in order to understand the structure, geometry and bonding process, what are the involved in the organic compounds. So basically in this particular topic we are going to see the just overview of what is hybridization process and how sp3 and sp2 hybridization which is associated with the carbon atom and what are the different examples for that we are going to see. So before we start, let us first understand the concept of bond formation. As we know that the organic compounds are having a sigma bond and pi bond which are involved in that. Basically, if we say what is the bonding process, is bonding is nothing but what sharing of two electrons in between the two atoms. So basically there is a mutual sharing takes place in covalent bond formation, and during the bond formation as we know that the valence electron which are present, valence electron means the electrons which are present in the outermost shell of that particular atom, they involved in the bonding process. So as we know that electrons are located in the orbitals, as in the topic of atomic structure you must have understood what is the structure of atom. And as we know that the orbitals are having the electrons which overlap either axially or laterally, and depending upon they form the sigma bonds and pi bond. As we know that sigma bond is formed by axial overlap of atomic orbital where maximum overlap takes place, and that's why we say that the sigma bond is quite stronger. And in case of the pi bond there is a lateral overlap takes place where the very less overlap takes place. That's why that particular bond is, let us say, weaker as compared to sigma bonds. So for this particular bond formation we are going to see the basic examples related with the carbon atom. As we know that carbon atom is having 6 atomic number, and these electrons are distributed as in the orbitals 1s2, 2s2 and 2p2. So we can say in the valence shell you can here clearly see there are 4 electrons are present. So basically we can say there are 4 valence electrons which related with the valency of that particular carbon atom as a 6. So carbon can form the 4 bonds with the another equally molecule which is also like to involve in the bonding process. So these 4 electrons are form bonds with the 4 electrons from the hydrogen, and as a result of that you can see the CH4, that is methane molecule, is formed. Here you can see equally the bonding or we can say mutual sharing of electron takes place. So basically we can say the molecules which are earlier not having the octet complete are decided to share their electron mutually, and as a result of that their orbitals overlap, and as a result of overlap there is a mixing and recasting of orbital takes place in the different direction, and as a result of that we know that this particular methane molecules where the orbitals are overlap tetrahedrally, and the molecules is having tetrahedral structure and 109-degree bond angle. So as we know that at ground state carbon is having electronic configuration 1s2, 2s2 and 2p2. So these electrons if you want to accommodate, how they will accommodate in 1s2, one electron with parallel spin, another electron with anti-parallel spin, same in the 2s orbital. So this is a K shell. This is the first shell where this is completely filled, while if we see this particular another shell, that is L, as we know that K shell is the first shell from the nucleus, then after K there is a L shell which can accommodate 8 electrons, but there are presently only 4 electrons, 1 2 3 4. So 4 more electrons, if this they get occupied, the octet will be completed for the carbon. So this is a px is having single electron, py is having single electron, while pz is empty. So this is a ground state electronic configuration. And uh, in case of the methane, as we know that there is a sp3 hybridization. In the coming slide also we will see how this methane molecule is formed. So basically we are going to now discuss what is basically the process of hybridization. So basically we have to remember that hybridization is mixing of atomic orbitals which are having equivalent energy, and they form new orbitals which are having same energy, and they are oriented in the space. So basically we have to remember hybridization is nothing but the mixing of atomic orbitals. So atomic orbitals, they mix, and as a result of that they form new orbitals which are having same or equivalent energy and definite orientation space. So that is very responsible for having a definite geometry and bond angle which is present for every molecule. So remember what is hybridization process. Okay, so this is nothing but the process of mixing of atomic suborbitals to form new orbitals which are called as hybrid orbitals. As we know that orbitals are of 4 types, they can be denoted that, as we know that orbitals are having electrons, and during the bonding process these electrons get exchanged or get shared in between the two atoms. So these orbitals are s, p, d, f. As we can see that the shape is, for s orbital is spherical where nucleus is at the center. For p orbital it is just like a dumbbell shape, and you can see the nucleus is at the middle. So this is a nucleus, so and this is a p orbital. Many times we draw like this. So this is a p orbital, and while d orbital is having elongated dumbbell shape. Here you can see there is a elongated dumbbell shape, and where the nucleus is at the center. Okay, so presently we will see only SPD, and there is one more orbital that is called as F. Okay, so these are the orbital shapes. These are very important in order to understand the shape, because in the mixing process we must know how these particular orbitals are mixed and they form the orbitals with different geometry. So this is related with the orbitals. Now we'll see what is the process of hybridization. Basically, when hybridization takes place, what exactly process takes place? The first step of the hybridization is the excitation of electron. As we know that the electrons are present first in the ground state. Okay, so once they are present in the ground state, they get excited to higher energy state, and in the excited state basically what happens, whatever the paired electrons are there, you can see the unpaired electrons are present. So basically during the excitation the paired electrons are getting excited to higher energy level and they get unpaired, and that is equal to their valency of that particular atom. Then next is when there is a excitation takes place, the hybrid orbitals forms a stronger bond during the overlap, and they are reoriented in the different direction and having a very particular shape which can be very easily explained in order to study their bonding and hybridization. So the whatever after the mixing the molecule is having a definite shape, so which is related with its geometry. So they once it get reoriented, it is having shapes, let us say trigonal, tetrahedral. So definite geometry you can explain. So with the help of geometry you can also explain how there is a bonding process is involved, what is the bond angle present in between the two atoms. So remember the process: excitation. Once the excitation takes place, in the excitation there is a unpaired electrons are present which is equal to its valency, and then there is a process of mixing of orbital takes place, that is being called as a actual hybridization. And once they are mixed, they are reoriented in a space to explain its shape. Now let us say in case of the carbon, as we know that carbon is having atomic number 6, these electrons are distributed as 1s2, 2s2 and 2p. So basically in the ground state you can see the 2s orbital is filled and 2p x and 2p y is having single unpaired electron. So in the excited state what will happen, this particular electron 2s electron will get excited and promoted to vacant 2pz orbitals. So here you can see the one of the electron from 2s is getting promoted to 2pz. So now you can see there are 4 unpaired electrons, 1 2 3 4. So that's why the valency of the carbon is 4. Why? Because the carbon in the excited state is having 4 unpaired electrons, and now in order to have the stability, that particular carbon is going to overlap or form bond with the 4 different atoms, and that's why we can say it is the combining capacity. Friends, carbon कितने friends बना सकता है? That is equal to 4. So that's why the valency of carbon is 4. कार्बन की वैलेंसी 4 क्यों है हमें अभी पता चल सकता है, बिकॉज इन एक्साइटेड स्टेट इट गेट्स promoted from one of the electron from 2s to 2pz. So that's why we can say this particular. And during sp3 hybridization 1s and 3p orbitals overlap to form new sp3 orbitals. So that is in case of the methane molecule we have seen. And this is how these orbitals are oriented in space, and they are having the bond angle around 109 degrees in between the two. So this is a tetrahedral structure. Here you can see here is basically in the center is nucleus, and we can see the 4 sp3 orbitals 1 2 3 4, they are oriented in a space in a tetrahedral manner and with bond angle 109 degree. Now let us see first hybridization for the carbon, that is sp3 hybridization. So what is sp3? We have to remember s के सर के ऊपर क्या है 1 है, so 1s and 3p orbitals. So remember how you can define the sp3 hybridization. So always you have to remember it is a mixing of 1s orbital and 3 2p orbitals to form new 4 sp3 hybrid orbitals which are having equal energy. So this particular hybridization is also called as a tetrahedral hybridization or sp3 hybridization. Why tetrahedral? Because once they mix they form the tetrahedral shape. That's why the particular sp3 hybridization is also called as a tetrahedral hybridization. So as we know that carbon is having sp3 hybridization with atomic number 6, and this particular during the hybridization process 4 sp3 orbitals are arranged in a such a way their axis they are towards the corner of regular tetrahedron with the carbon located at the center. So this is already we have discussed. Ground state, this is a electronic distribution 1s2 2s2 2p2. In the excited state what will happen, the one of the 2s electron gets promoted to 2pz. So you can see here now there are 4 vacant orbitals are having same energy. Why same energy? Because all the electrons are in the 2 second shell, so that's why they are having equivalent energy. So as they are having the equivalent energy they combine and they form the 4 new sp3 orbitals, and these sp3 orbitals are having of equal length, equal energy, and they are tetrahedral in shape. Already we have discussed in the last slide. So basically what happened, s orbital 2s orbital is having spherical shape, p orbital let us say px, py and pz. These are the 3 orbitals. So 1s and 3p orbitals 1 2 3 px, py, pz, they combine and they form new sp3 hybridized orbital which is having shape like this, where we can say one of the lobe is bigger in size and one of the lobe is small in size, that is it is a shrinked. So we can see the new orbital is having this particular shape sp3. So this is a 1s orbital, 1 sp3 orbital. There are 4 sp3 orbitals are formed and which are oriented in a space in this particular direction, and you can see the bond angle 109 degree 5 minutes. So this is a tetrahedral geometry, and these orbitals are oriented at the corner of regular tetrahedron. So remember when we explain the sp3 hybridized orbitals, so these are the sp3 hybridized orbital, or this one which is having 25% S character and 75% P character. So remember the percentage of P character is higher. So we can say in the sp3 orbitals they are having 25% only S character and 75% P characters. So as we move from SP3 to SP2 to SP, the percentage of S character will increase gradually. So remember this particular characterization. This is very important. So as we have seen, SP3 is having this one is larger lobe, this one is having smaller lobe. As in case of the methane, as we know that methane is a very good example of SP3 hybridization for the carbon. So this remember this particular example for methane. And in case of the methane, there are 4 CH bonds. This particular CH is having bond length 1.09 Armstrong, and that particular bond energy is around 102 kilokelvin. So in case of the methane, as we know that for the carbon, these are the black electrons which are there, and this particular electron is coming from the hydrogen. So these 4 electrons are accommodated in this particular shape, and here you can see that there is a sp3 hybridization takes place. So 4H and one sp3 hybridized orbital, they combine to form new methane molecules. So here you can see the methane molecules. So there is a S and sp3 overlap takes place to form this particular bond in between carbon. As we know that there are 4 CH bond. So these 4 CH bond are formed by the overlap of s orbital of hydrogen and sp3 orbital of carbon. So there is s dash sp3 overlap takes place. So this particular bond is formed by the overlap of sp3 and s orbital, and here you can see the geometry with bond angle 109 degree. Now let us see the example of sp2 hybridization. So what is sp2 hybridization basically? So sp2 hybridization is nothing but the mixing of 1s and 2p orbitals. Remember always 1s and 2p orbitals to form new 3 sp3 hybridized orbital which are having equivalent energy, and they form the trigonal geometry. So it is also called as a trigonal hybridization. Remember sp2 is the trigonal hybridization. You can also predict what will be the bond angle. So bond angle will be around 120 degree and trigonal symmetry. Just trigonal means just like a triangle. So this is how we can say the triangular planar shape these are having the sp2 hybridized orbital. So let us see how the sp2 hybridized orbitals are formed. Carbon atomic number 6, 1s2, 2s2, 2p, to ground state electronic configuration. In the excited state, what will happen? This 2s will get promoted to 2p. So as there is only 1s and 2p orbitals, overlap will take place. So you can see only these 2p orbitals will overlap, and one of the pz orbital will remain as it is unhybridized. So in the bonding process, only 1s and 2p orbital will take place, while one of the pz orbital will remain as it is. It will not take part in the bonding process. So in the hybridization of sp2, correct here sp2, so the 1s will remain as it is, and these 3 orbitals are they formed to form the sp2 hybridized orbitals, and this will remain as it is. So as we know that pz orbital does not take part in the hybridization process, and it always remain perpendicular to the plane of the sp2 hybridized orbitals, and it may be utilized for the formation of pi bond. So pi bond electrons remain above and below the plane. As we know that there is a overlap takes place above and below the axis. So here you can see, so these are the sp2 hybridized orbitals which are oriented at the triangular manner and having 120 degree, and one of the pz orbitals here you can see with the violet color, so it is became unhybridized. So it is just like this, the pz orbital is in this plane, while sp2 orbitals are one at this direction, one at this direction, and one at below direction. So it is just like a triangular shape. So this is a top view we can see, and this is a side view. This is also we can see sp2, 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 and pz remain as it is unhybridized, which is perpendicular to plane. So remember it from the triangular plane geometry. If somebody asks you what is the geometry for sp2 hybridization, so remember it is a triangular. What is the example for sp2 hybridization? It is a ethene CH2 double bond CH2. Let us see how this particular bonding is formed. In order to study the bonding process, we must know how electrons are distributed: 1s2, 2s2, 2p2. So in case of the overlap, what will happen? Only 3 hydrogens which are overlap, and they will form the 3 sp2 hybridized orbital. So here you can see the bonding process. So carbon carbon, these two carbons will overlap by sp2 hybridized orbital of this particular carbon and sp2 hybridization orbital of this particular bond. So this particular sigma bond in between the two carbon, as we know that in case of the ethene there are two bonds, one is two bonds, so we can say there is a double bond in between the carbon carbon. Here you can see there is a double bond. So one of the bond is sigma bond, which is formed by the overlap of sp2 orbital of one of the carbon and sp2 orbital of one of the carbon. So this particular carbon is formed by the sp2 sp2 overlap, while there is a 4 ch bond, as they are formed by s overlap and sp2 overlap, sp2 sp2 s overlap. So this is how we can say. And whatever the pz orbital which is present, that will overlap laterally and it will form the pi bond. So always remember, in case of the ethene there is a one sigma bond and one pi bond which is formed by the lateral overlap of pz orbital, while this particular single bonds, as we know that single bonds are always formed by the sigma bonds, but in case of the double bond there is a one sigma bond and one pi bond. So this is how we can explain the bonding process. So always remember this particular diagram, ball and stick model. So sigma bond is formed by sp2 sp2 overlap, while pi bond is formed by sp2 sp2 overlap. So there is a you can see one is sigma bond, one is pi bond, and bond angle is almost 120 degree. So this is also, you can see the electronic distribution, the side view, pi bond here you can see, and here is the sigma bond. Okay, same diagram here also we can explain. Here you can see the two electrons are shared, one individual by carbon by sp2 sp2 overlap. So this is again sp2 sp2 overlap, pi bond here, as we know that there is a pz orbital. So this is how we can explain. H S sp2 S sp2 S sp2 S sp2. So this is how this particular bonding is processed. So each carbon atom has 3 triangular hybridized orbitals, and these orbitals are perpendicular to plane, and they approach to overlap and form the bonds. So this is how we can say the ethene molecule is formed by the sp2 hybridization of carbon. So go through this particular hybridization, SP3 and SP2. What is the example for SP3? It is a methane molecule, and for SP2 it is ethene molecule. For SP hybridization for carbon, we will see in the next session. Thank you. Till then, take care. Goodbye.